Hey guys, welcome back. We're going to finish off here a little bit more of 4.1 on the properties of gases and some of our elementary gas laws. Last topic we talked about Boyle's law, which was the relationship between the pressure and volume of a gas if everything else stayed the same. So we're kind of thinking about like that whole balloon idea: pressure, volume, temperature. We're talking about gaseous states. We're trying to figure out what's going on when we start to play or manipulate some of these things. As we start talking about temperature, there is a huge issue with how we look at temperature when we talk about a gas. The most common ways that we look at temperature in our everyday lives would be Celsius here for us in Canada, Fahrenheit for our American friends, but neither of those work well. They have their issues. Number one, Fahrenheit. I'll put a video online here, or at least into the gas laws section here, that talks about the differences between Fahrenheit and Celsius, and it's absolutely fascinating. But Fahrenheit was picked arbitrarily. When he did his work with temperature, it was all good, it's all valid, but it was just arbitrarily picked for his convenience. Celsius, when he did his work, arbitrarily picked some better points, but it still built off Fahrenheit's work. Celsius chose things like 0 was going to be the freezing point of water, and 100 was going to be the boiling point, and he made all of the other divisions in between. It's interesting. It's a fascinating look into science and what science is. So if you're curious about this, I hope you will look at the video. It will be in this lesson here, and it's awesome. But here's the issue. When we take a look at either of those two scales, both of those have negatives and arbitrary zeros within them. When we get to Chemistry 30, we'll talk about what thermochemistry is, and we're going to find out that temperature, the way we describe hot or cold, has absolutely nothing to do with warm or cool. It actually has everything to do with molecular motion. So temperature is really just only a measurement of how fast or how slow a particle is moving. And if we think about that, there's really no such thing as less than zero movement. So we have an issue. This brings us to the Kelvin scale. When we take a look at this, we are looking at an absolute temperature. The volume of a gas will change with temperature. We make some restrictions. If gas does not liquefy and condense as it cools, then there is a threshold point. If a gas ever were able to reach negative 273 degrees C, then all molecular motion would stop and it would have a volume of 0. This is kind of a messed up point. What this means is you're reaching deeply into theory. This really hasn't happened, but all of our math says it would. So we call this point absolute zero. This means minus 273 is the coldest anything can get. When we keep going, Kelvin came up with a temperature scale based upon this idea of absolute zero and molecular motion stopping. All right, we have typical values here, and then he just extrapolated back to when a volume of a gas would equal 0. And there's your minus 273. No matter what temperature scale we use or what gas we used, he always reached the same point. So we have a bit of an issue. This means that we can come up with a temperature scale that has no negatives within it. While not convenient for talking about the weather today, super convenient for talking about gas laws and how they behave. So we need to learn one thing, and it's super simple: converting between Kelvin and Celsius. Kelvin is a temperature scale, Celsius is a different temperature scale, Fahrenheit is yet another temperature scale. This is not too different than metric system. imperial system and let's say old Egyptian system. All these things are all somewhat comparable. You're trying to describe the same things. You're just using different numbers and units to do so. So we must be able to convert between Kelvin and Celsius. It's pretty simple. Kelvin is going to be equal to the temperature in Celsius plus 273 degrees C. That's it. So, if it is 0 degrees Celsius, what is the temperature in Kelvin? It is 273. If it is 20 degrees Celsius, what is the temperature in Kelvin? Pretty simple. It is 293 C. 20 plus 273. If it's minus 20 outside, like it was just the other day, minus 20 plus 273 would equal 253. So all of your numbers in the Kelvin scale are positive, and this is absolutely necessary because it relates to something that we're ultimately trying to look at when we measure temperature. All right, a bit confusing right now, but I hope some of that made sense. What we want to do now is talk about Charles' law. Charles' law is just a second gas law. It was discovered about 100 and some odd years later after Boyle's law, and he was just looking at the relationship between temperature and the volume of a gas. What he's doing is making sure that the amount of gas stays the same and the pressure on the gas stays the same. So he's really restricting this, much like Boyle did, to kind of an unrealistic situation. But we're looking at one manipulated variable and one responding variable. He states that as temperature increases, the volume increases as well. And you can see that. As the temperature gets bigger, so too does the volume it occupies. This just means that as you add temperature to a gas, the particles move faster, and therefore they would spread out more quickly. Therefore, we measure this as volume. Very much like what Boyle did, he realized that the volume and temperature situation equaled a constant, and this was something that was not variable. Therefore, he was able to put together a relationship that if you had volume and temperature information, and you decided to go mess with one and change it, the situation to situation 2, that as one thing increased, the other thing would have to increase as well. So this gives us a little bit of a situation. This is a constant. It provides us with this equation. The second one you want to memorize as Charles' law. Guys, I appreciate the fact that you don't want to have to memorize, but this is the easiest way to get through our basic gas laws, which is the first part of our gas laws unit. There will be a better way as we go forward, but for right now, these questions are done through memorization. PopCan demo, I will figure out a way to show you guys this at home without blowing up my kitchen, but ultimately I will find some sort of video to show you this. All right, so right now we're just realizing that Charles' law is a relationship between volume and temperature, and it is a direct linear relationship. Sound good? I hope so. Here we go. Next video we'll have the examples to show you what this looks like on paper and with the math. Keep it up, guys. See you in the next video.